This is a meta-analysis of scientific studies done on machine learning-based systems. In the abstract, they found 17 fields where errors existed, affecting 329 papers and in some cases leading to wildly over-optimistic solutions. And one of the things that they discovered, among others, so let's pop this open. While they went through all of these papers and broke down like what exactly they were looking for, etc., essentially the summary is a lot of these scientific papers, or at least a non-zero amount of scientific papers, have a basis, a fundamental basis of bad foundations. One of the problems, data leakage. Does anybody know what data leakage is? What's a data leakage in terms of machine learning or LLMs? LLMs in general, even. Let's see if chat knows. Anyone in chat, do you guys know what data leakage is? Data leakage is when the training data, it leaks over into the training of the model. In other words, the model is supposed to sometimes operate based on not exclusively using the like it's supposed to exclude the training data. That's what I'm trying to say. When you're training an LLM, what you're supposed to do is tweak the internal black box and, do whatever you have to do in order to get it to figure out what outputs are correct given a certain set of prompts. Data leakage is when the training data is referenced as part of the answer that an LLM gives. Why is that bad? It's bad because what you're doing at that point is you're not accounting for the fact that the LLM didn't actually learn anything. It didn't actually tweak its own internal box to provide proper output. All it did was reference the training data and then provide the output. Now that's one issue. So they found that this happens on a number of scientific studies of machine learning models. And the other issue is that they also couldn't even reproduce some of the studies. So you have a whole bunch of studies that they broke down here. That's fine. They use specific terms, et cetera, et cetera. And they realized that the either admittedly within the scientific study or as a result of looking objectively at the results of the scientific study, they could determine when the model used the training data as a self-reference. It's kind of like the circular reference of it's good because it's good because it's good. The answer is the answer because I have the answer because it's the answer. That's essentially the problem here. And then you add in the fact that when they try to recreate, which is one of the most fundamental principles of any scientific study, is you're supposed to be able to take data and you're supposed to pass a series of steps off to someone else such that they can reproduce that study with that data and come to the same outputs. Their conclusions based on those outputs might be different, but the same inputs and outputs can be used, and they can't even do that. And we already know this is a problem in software. We have a bunch of software-based scientific studies that are also not producible in large amounts. I believe when we went over that on a previous Daily Tech News stream, it was something like over 50% or something like that of scientific software studies, software-based studies, could not be reproduced. So this puts into question a lot of the empirical evidence, a lot of the statistical evidence, a lot of the surveys done, a lot of the benchmarks. We've gone over this as well, where benchmarks are tweaked. Rather, that's an incorrect statement. LLMs are tweaked to pass benchmarks. They'll be fed training data. These machine learning models will be fed training data that is catered to passing benchmarks that they want to pass in order to look good. And then that training data is not exactly the same data that is trained on the consumer-facing stuff that you use when you open up your web browser and go to ChatGPT. So this is a very bad start to the scientific method with regards to machine learning models and their overly optimistic outlook based on studies that they've done. Now, there were a few other things in this in this particular uh, um, study that did talk about some of the biases that came from the training data itself, which I thought was also interesting. There were some biases on the what the scientific study was being used to do. So you can imagine, for example, someone is trying to figure out whether ChatGPT is good at medical stuff. I think they bring up pneumonia here, pneumonia prediction trained on images, right? However, it was only from one hospital, right? This is a problem, is that even if you do have non-data leakage and you have training data that you can pull and use to reproduce the study, the issue is that the training data itself, it also comes with biases. It's like selection bias, limitations, it's not comprehensive enough, etc., etc. So just at its face, this shows some very serious concerns. At least it's not like you can make a wide, broad general statement, all scientific studies on machine learning models is bad. But there is an issue here where you really have to ask and read. You unfortunately have to read and not trust any of the scientific papers based on the outputs of machine learning models. They did compare to some older models to see whether older models performed better or worse. And they actually found that older models that were less complex and far more limited and had a far narrower but maybe more like broadly or diverse heavy set of training data, if you could even call it training data at the time, they did tend to perform better, which goes to a very particular point that we've talked about here before, which is that we've had these kinds of algorithmic systems for a long time. And when you narrow down the algorithms to solve very specific problems, you're going to get far better results. It's what we do when we code to begin with. These LLMs, machine learning models, are just fancy, bloated code-based algorithms that we create to solve problems all the time. We just kind of put it away in a black box and we go, well, we don't know exactly how this works. There's math and weights and stuff like that. But when you narrow down the scope of the entirety of the model itself, the underpinnings, the foundational stuff, yeah, of course, it's going to look a lot more like someone created a code-based algorithm to systemically go through something and generate stuff. We did that all the time when you did things like, what do you think AWK is? Or when you do grep, it's like that. It's akin to that.